What if I told you that right now, at this very moment, there are beings looking up at their night sky, wondering if they're alone in the universe, while we're looking at them through the most powerful telescope humanity has ever built? On March 17, 2024, the James Webb Space Telescope detected something that sent shockwaves through the astronomical community. Dr. Natalie Bataya, the exoplanet researcher who's dedicated her career to finding another Earth, was analyzing spectroscopic data from a planet designated LHS 1140b when her hands started trembling. The chemical signature she was seeing wasn't just unusual, it was impossible, unless someone was already living there. The atmospheric composition showed technosignatures, industrial pollutants, chlorofluorocarbons, the same chemicals that nearly destroyed our own ozone layer in the 1980s. But here's what made her drop her coffee mug that morning. These signatures were fresher, stronger, and more complex than anything we've ever produced. This wasn't ancient. This was active. This was now. For 72 hours, NASA went into complete media blackout. The world's leading astrobiologists were pulled into classified briefings. And when the information finally leaked through a junior researcher's encrypted message to a colleague, the scientific community faced a crisis that nobody had prepared for. We found Earth 3.0, we found paradise. And somebody else got there first. But here's what's going to absolutely shatter your understanding of reality. They might have been watching us for longer than humans have existed as a species. Before we dive into the most profound discovery in human history, I need you to do something. Hit that subscribe button. Smash that like. Because what you're about to learn in the next 3.5 hours will fundamentally change how you see your place in the cosmos. And I want you to comment below. What country are you watching from? And what time is it where you are? Because right now, across this planet, people are waking up to the same stunning truth. We are not alone. We never were. Let me take you back to how we got here, because the story of finding Earth 3.0 is actually the story of humanity's greatest obsession, finding ourselves reflected in the cosmos. The James Webb Space Telescope launched on December 25, 2021, Christmas Day, while families were opening presents. A 30-year, $10 billion bet was being placed into orbit. Dr. John Mather, the senior project scientist who won the Nobel Prize for his work on cosmic background radiation, called it looking at the universe with the lights finally turned on. Think of it like this. For all of human history, we've been trying to see the universe through a foggy bathroom mirror. Hubble? That was us wiping away some of the condensation. Webb? That's stepping outside into crystal clear air and realizing the mirror was blocking a window to infinity. Webb doesn't detect visible light like our eyes do. It sees in infrared, heat signatures, the radiation that life itself produces just by existing. And when we pointed it at a star system 49 light years away in the constellation Cetus, we weren't expecting what we found. LHS 1140b orbits a red dwarf star. Now, red dwarfs are the universe's cockroaches. They're small, they're dim, they last for trillions of years, and 99.9% of them are completely hostile to life. But LHS 1140b sits in what Dr. René Doyen, the Canadian astronomer leading the atmospheric analysis team, calls the Goldilocks zone on steroids. The planet is roughly 1.7 times Earth's size. Surface gravity would make you feel about 30% heavier, like wearing a weighted vest at the gym all day. One side permanently faces its sun, locked in eternal day. The other side? Frozen twilight forever. But along the Terminator line, that narrow band between eternal light and eternal darkness, temperatures hover between 15 and 25 degrees Celsius. Perfect. Here's where it gets interesting. When Webb analyzed the light filtering through this planet's atmosphere during transit, something extraordinary appeared. Dr. Sarah Seeger from MIT, who literally wrote the textbook on exoplanet atmospheres, identified water vapor. Lots of it, She found oxygen at 21% concentration. She found nitrogen, argon, trace methane from biological processes. She found Earth's twin. But then, buried in the spectroscopic data, hidden in absorption lines that required 18 months of analysis to confirm, the team found something else. Fluorinated gases that don't occur naturally. Complex hydrocarbons and ratios that only industrial chemistry produces. And here's the detail that changed everything. The isotopic signatures were wrong. See, when we burn fossil fuels here on Earth, we release carbon-12 preferentially over carbon-13 because ancient plants preferentially absorb the lighter isotope during photosynthesis. It's a signature, a fingerprint. And LHS 1140b's atmosphere showed the exact same pattern. Someone over there was burning their planet's ancient life to power their civilization. Just like we did. Just like we're still doing. What if I told you that we might be looking at ourselves 49 years in the past, making the same mistakes we made, heading toward the same climate crisis we're desperately trying to avoid? But that's not even the mind-blowing part. Here's what should have been impossible. The development timeline. Dr. Lisa Kaltenegger, who runs Cornell's Carl Sagan Institute and literally maps potentially habitable worlds for a living, ran the numbers. And the numbers don't work. They break everything we understand about planetary evolution. LHS 1140, the star, is approximately 5 billion years old, same age as our sun. But here's the problem. Red dwarf stars take longer to stabilize, much longer. For the first 2 billion years of this star's life, it would have been a violent, radiation-spewing monster that would have sterilized any planet in its vicinity. UV radiation levels would have been 10,000 times higher than Earth experiences. Any atmosphere would have been stripped away like paint in a sandblaster. So life on LHS 1140b had, at most, 3 billion years to evolve from single-celled organisms to industrial civilization. Here on Earth, that same journey took 3.8 billion years, and we barely made it. 5 major extinction events nearly reset the clock completely. The Permian extinction wiped out 96% of all species. The asteroid that killed the dinosaurs was just 66 million years ago, a cosmic blink. Dr. Adam Frank from the University of Rochester, who studies the life cycles of civilizations, calculated the probability for a planet to develop technological civilization in 3 billion years. Given everything we know about evolutionary biology, chemistry, and planetary science, the odds are approximately 1 in 800,000. Yet, there it was, broadcasting its industrial revolution into space for anyone with sophisticated enough instruments to detect. Unless, and this is where your brain is about to start hurting, unless they had help. Think of it like this. Imagine you're trying to solve a 10,000-piece jigsaw puzzle, but someone already put together the corner pieces and sorted the edges for you. You'd finish way faster than someone starting from scratch, right? What if evolution on LHS 1140b didn't start from scratch? Here's what will blow your mind. In 2023, before we even detected the technosignatures, Dr. Avi Loeb from Harvard published a paper suggesting that life in the universe might not evolve independently on each world. Instead, it might spread. Panspermia. Bacteria and organic molecules riding asteroids and comets between star systems, seeding world after world with the building blocks of life. But Loeb took it further. He suggested that advanced civilizations might intentionally seed planets. Directed panspermia. Genetic engineering on a cosmic scale. When the LHS 1140b data came in, someone on his team ran a genetic likelihood analysis based on the atmospheric biosignatures. The photosynthetic processes producing that oxygen, they showed the same fundamental chlorophyll structure that Earth's plants use. The same light-harvesting complex 2-protein configuration, down to the molecular level. The probability of that evolving independently, less than winning the lottery 100 times in a row. They weren't just our neighbors. They might be our cousins. Now, I need you to understand something crucial. Everything I've told you so far, NASA confirmed publicly. Reluctantly, after the leaks, but they confirmed it. Atmospheric composition? Public. Industrial signatures? Public. Timeline anomalies? Public. What I'm about to tell you. This is where it gets classified. This is where scientists started having very quiet, very serious conversations about whether humanity was ready for this information. 3 months after the initial detection, Dr. Jill Tarter, the astronomer who inspired the movie Contact and spent 40 years searching for extraterrestrial intelligence, detected something in the radio spectrum coming from LHS 1140b's region of space. Not random noise, not natural cosmic radiation. A pattern. The signal repeated every 11 hours and 17 minutes. That's not arbitrary. That's LHS 1140b's exact rotation period relative to Earth. Someone was broadcasting in sync with their planet's rotation, ensuring maximum coverage of their sky during each cycle. The signal itself was encoded in prime numbers. 2, 3, 5, 7, 11, 13. The universal language of mathematics. The same technique we used in the Arecibo message we sent to the stars in 1974. The same logic we've been using to say, we're here, we're intelligent, we understand the universe mathematically. But here's what made Dr. Tarter's hands shake when she isolated the signal component. Embedded within the prime number sequence was a secondary pattern, a rhythm. When she converted it to binary and then to a visual representation, it showed something that looked disturbingly familiar. A helix, the double spiral of DNA, not their DNA, our DNA, the specific base pair ratios of human genetic material, adenine, thymine, guanine, cytosine, in the exact proportions that define Homo sapiens. They were broadcasting our blueprint back at us. Now, think of it like this. Imagine you're in a forest and you shout, "Hello," expecting an echo. But instead of hearing your own voice bounce back, you hear someone shout your full name, your birthday, and your social security number. That's the level of what the hell is happening we're dealing with. The signal had been broadcasting for at least 49 years, because that's how long light takes to travel from there to here. Which means they detected us, analyzed us, and started responding in the mid-1970s. Right around the time we were sending our own first serious messages to the stars. Right around the time Voyager 1 and 2 were launched carrying golden records with human voices, music, and images. But there's a problem with this timeline. A massive, reality-breaking problem. For them to receive our signals, analyze human DNA somehow, and send a response, the absolute minimum time required would be 98 years. 49 years for our signal to reach them, 49 years for the response to reach us. We only started broadcasting powerful radio signals in the 1930s. The math doesn't work. Unless they were already watching. Unless they knew what was here before we announced ourselves. Dr. Seth Shostak from the SETI Institute suggested something that made everyone in the room go silent. What if they've been monitoring Earth for thousands of years? What if they watched our civilization develop, waiting for us to reach the technological threshold where communication becomes possible? What if first contact didn't happen when we detected them? What if it happened when they decided we were finally ready to know they existed? Before we go deeper into what this means, I need you to pause and think about something. Right now, you're sitting somewhere on planet Earth, watching this video. But 49 light years away, if someone is looking at Earth with instruments as powerful as Webb, they're not seeing you. They're seeing Earth as it was in 1976. They're watching disco and bell-bottoms. They're observing the Cold War. They have no idea about smartphones, the internet, or climate change acceleration. And we're looking at them the same way, in reverse. We're seeing their 1976. We don't know what they've achieved in the last 5 decades. We don't know if they've solved their climate crisis or succumb to it. We don't know if the civilization we're detecting even still exists. We are two civilizations, separated by 500 trillion kilometers, looking at each other's ghosts. Stay with me, because what comes next is going to make you question everything you think you know about reality itself. Let me explain why LHS 1140b shouldn't just be rare. It should be impossible. Dr. James Casting, the geoscientist who literally defined what we call the habitable zone, spent decades calculating the precise conditions required for liquid water to exist on a planet's surface. Distance from the star, stellar temperature, planetary mass, atmospheric composition, magnetic field strength, geological activity. It's not just one thing. It's hundreds of variables that all need to align perfectly. The habitable zone around a red dwarf star like LHS 1140 is incredibly narrow. We're talking about a band maybe 3 million kilometers wide. For comparison, Earth's orbit around our sun varies by 5 million kilometers annually, and we stay comfortably habitable. LHS 1140b has almost no margin for error. But here's the paradox. Red dwarf stars are variable. They flare, unpredictably. A solar flare from LHS 1140 could increase radiation output by 500% in minutes. On Earth, that would be an extinction-level event. Ozone layer destroyed, surface temperatures spiking, oceans boiling in shallow regions. Yet LHS 1140b's atmosphere shows stable biosignatures going back decades based on our observations. No sudden die-offs. No recovery periods. Just continuous, thriving biological activity. How? Dr. Victoria Meadows, director of NASA's Virtual Planetary Laboratory, proposed something radical. What if they engineered their own solution? What if we're not just detecting a naturally habitable planet, but an actively managed one? Think of it like this. You know how we're talking about putting solar shields in space to combat climate change? Giant mirrors at the Lagrange point to regulate how much sunlight hits Earth? What if they did that thousands of years ago? What if the reason their planet stays stable, despite stellar flares, is because they built planetary-scale infrastructure to control their environment? The atmospheric data supports this. The CFCs we detected aren't distributed evenly. They're concentrated in bands. Specific latitudes, like a network. Like a system designed to maintain atmospheric chemistry in optimal ranges regardless of external conditions. We might not be looking at a civilization living on a planet. We might be looking at a civilization that turned their entire planet into a machine. A life support system on a scale we can barely imagine. But that raises an even bigger question. If they have that level of technological capability, why are they still producing industrial pollutants? Why haven't they moved to clean energy like we're desperately trying to do? Dr. Frank's answer chilled everyone who heard it. Maybe they did. Maybe what we're detecting isn't their current technology. Maybe it's their museums. Maybe they preserved their industrial age as a reminder of what not to do. Or maybe, he paused for a long time. Maybe they're sending us a warning. Maybe they're showing us our future if we don't change course. Look at what we did. Look at what it cost us. Don't make the same mistakes. What if Earth 3.0 isn't paradise? What if it's a cautionary tale, broadcasting itself across the stars? Now we need to talk about what these beings might actually be. And this is where science fiction meets hard science in ways that will make your head spin. Dr. Dimitar Sasolov, who directs Harvard's Origins of Life initiative, analyzed the atmospheric data with one question in mind. What kind of biology could thrive on LHS 1140b? The planet is tidally locked. One side always faces the sun. One side is always dark. The temperature difference between the two hemispheres would create permanent hurricane-force winds along the terminator zone. Atmospheric circulation would be violent and constant. Any life evolving there would need to handle extreme environmental stress as baseline normal. The oxygen concentration is slightly higher than Earth's, 23% instead of 21. That might not sound like much, but think of it like this. During Earth's Carboniferous period, when oxygen hit 35%, insects grew to terrifying sizes. Dragonflies with 2-foot wingspans. Millipedes 8 feet long. Higher oxygen means more efficient metabolism, which means organisms can grow larger and process energy faster. But here's what's fascinating. The spectroscopic data shows ammonia in the atmosphere. On Earth, ammonia is toxic to most complex life. But some extremophile bacteria use it as an energy source. What if on LHS 1140b, ammonia-based biochemistry isn't extreme? What if it's normal? Dr. Sarah Emery Walker, a physicist who studies the origins of life, proposed something that sounds like science fiction. What if life there evolved with a fundamentally different architecture than Earth life? We use DNA and RNA, 4 nucleotide bases storing genetic information. But mathematically, you could build a genetic system with 6 bases, 8 bases, 12 bases. More bases mean more information storage density, more complex organisms possible with smaller genomes. Evolution could proceed faster, more efficiently, with fewer dead ends. When NASA's astrobiology team modeled what 6 base pair life could achieve, they found something startling. Complex nervous systems, what we'd call brains, could evolve in roughly 1/3 the time required for 4 base systems. Tool use, language, abstract thinking, all accelerated. That might explain the timeline problem. They didn't evolve faster than us, despite having less time. They evolved faster because their biochemistry is literally more efficient than ours. But here's what keeps scientists awake at night. If their biology is that different, if their fundamental life chemistry operates on different principles than ours, then the signal we detected, the DNA sequence they broadcast back at us, represents something terrifying. They didn't just detect our radio signals. They somehow analyzed our biology across 49 light years of space. They understood our genetic code. They decoded the molecular basis of human life. How? Dr. Loeb suggested something that sounds impossible: quantum entanglement. The universe's weirdest trick, where particles can be connected across any distance instantaneously. What if biological molecules can become entangled? What if, when panspermia spread life across the galaxy, it created a network of quantum-connected organic compounds? What if they can sense Earth life directly because we're all connected at the quantum level, branches of the same cosmic tree? I know that sounds insane, but quantum biology is a real field. Birds use quantum entanglement in their eyes to navigate using Earth's magnetic field. Plants use quantum effects in photosynthesis. Life already uses quantum mechanics. We just don't understand how deep it goes. What if I told you that you might be quantum entangled with an alien 49 light years away right now, and you'd never know? We need to talk about the Kardashev scale because it's about to become very relevant to your life. In 1964, Soviet astronomer Nikolai Kardashev proposed a way to classify civilizations based on energy consumption. Type I civilizations harness all the energy available on their planet. Type II civilizations harness all the energy of their star. Type III civilizations harness all the energy of their galaxy. Here's the uncomfortable truth. Humanity isn't even Type 1 yet. We're Type 0.73. We use about 73% of Earth's available energy. Dr. Michio Kaku, the theoretical physicist, estimates we'll reach Type 1 around the year 2200, assuming we don't destroy ourselves first. Now, LHS 1140b's civilization, based on the atmospheric data, the distribution of industrial signatures, and the energy requirements to maintain planetary scale environmental management, Dr. Frank calculated they're approximately Type 0.9, just slightly ahead of us, maybe a century or two more advanced. Think of it like this. They're not gods. They're not infinitely beyond us. They're like us meeting someone who grew up with smartphones, while we grew up with rotary phones. Different, more advanced in some ways, but fundamentally similar. Except here's the thing that doesn't make sense. A Type 0.9 civilization should be blindingly obvious in the electromagnetic spectrum. Their radio transmissions, television broadcasts, cellular networks, satellite communications, all of it should be screaming across space. We should have detected them decades ago with basic radio telescopes. But we didn't. We needed the James Webb Space Telescope looking in infrared at atmospheric chemistry to find them. All the radio searches came up empty. Dr. Tarter, who spent 40 years listening for alien radio signals, had to confront a disturbing possibility. What if they're quiet on purpose? What if they're hiding? But hiding from what? What could a civilization with planetary scale engineering fear? The dark forest hypothesis, proposed by Chinese science fiction writer Liu Cixin, but taken seriously by many scientists, suggests a terrifying answer. The universe is silent because civilizations that broadcast their existence get eliminated by older, more powerful civilizations who see them as threats. If you're in a dark forest and you don't know who else is there, you stay silent. You hide. You survive by not being found. What if LHS 1140b's civilization learned that lesson? What if they're radio silent because something taught them to be quiet? And if that's true, what are we doing broadcasting our existence to the cosmos? What happens when whatever scared them finds out about us? Dr. Stephen Hawking, before his death, warned against trying to contact alien civilizations. He said, if aliens visit us, the outcome would be much as when Columbus landed in America, which didn't turn out well for the Native Americans. We found them. We announced it to the world. We can't undo that. What if we just rang the dinner bell? I want you to do something for me. Look up at the night sky tonight. Find the constellation Cetus, the sea monster. LHS 1140 is there, a dim red star you can't see with your naked eye, but that's burning steadily in space. And know that right now, at this very moment, photons are leaving that star system, carrying information about a civilization that might be looking back at us. Those photons are racing through space at the speed of light, and in 49 years, they'll arrive here carrying the answer to whether they still exist. We're in a conversation with a 49-year delay between responses. By the time we hear back from any message we send now, you'll be 98 years older. Your grandchildren will hear the response. We're not having a conversation. We're passing messages across generations, across lifetimes, across the vast emptiness of space. And somehow, that makes it more profound. There's a concept in astrobiology that's going to become very important to understanding what LHS 1140b means for humanity. It's called the Great Filter, and it's absolutely terrifying. The Fermi paradox asks, if the universe is so vast and so old, why haven't we found aliens everywhere? Where is everybody? The Great Filter hypothesis, proposed by economist Robin Hanson, suggests there's some evolutionary step that's incredibly difficult to pass. A filter that eliminates most civilizations before they can spread across the stars. And the question that keeps scientists awake at night is the filter behind us or ahead of us? If it's behind us, if the hard step was something like the origin of life itself, or the evolution of complex cells, or the development of intelligence, then we're past the danger zone. We're the lucky ones who made it through. The universe should be full of planets with bacteria, but technological civilizations like us should be incredibly rare. But if the filter is ahead of us, if the hard step is something that civilizations face after they develop technology, nuclear war, climate collapse, artificial intelligence gone wrong, nanotechnology gray goo, something we haven't even thought of yet, then we're in the danger zone right now. Dr. Frank studied the lifespans of civilizations. He looked at every human civilization that ever existed and calculated how long they lasted from peak complexity to collapse. The average? About 340 years. The United States is 248 years old. Western industrial civilization is about 250 years old. We might be approaching the statistical danger zone right now. But here's what LHS 1140b tells us. At least one other civilization made it past type 0.9. They survived their industrial revolution. They're still there, managing their planet, existing. Unless they're not. Remember, we're seeing them as they were 49 years ago. We're looking at 1976 over there. We have no idea if they survived the last 5 decades. We don't know if they solved their climate crisis or if their civilization collapsed. We don't know if they're thriving or extinct. We're looking at Schrödinger civilization. Until we get more current data, they're simultaneously alive and dead. Dr. Kaltenegger proposed a terrifying thought experiment. What if we're looking at a dead civilization's final broadcast? What if those industrial signatures are the chemical ghost of a society that destroyed itself, and we're just now seeing the light from their collapse? The CFCs in their atmosphere will persist for thousands of years. The atmospheric scars of industrialization don't heal quickly. We could be looking at a tomb, a monument to failure, and not even know it. But there's another possibility, one that's equally mind-bending. What if they transcended? Dr. Paul Davies, the physicist and astrobiologist, suggests that sufficiently advanced civilizations might not stay biological. They might upload themselves into machines, into computational substrates, into forms of existence we can't even imagine. They might abandon their planet entirely, leaving it as a museum, a nature preserve, while they explore existence in virtual realities or quantum computational spaces. The industrial signatures we detect might be automated systems maintaining an empty world. Caretaker machines keeping the lights on for a civilization that evolved beyond needing planets at all. Think of it like this. Imagine you're a caterpillar and someone tells you that someday you'll be a butterfly. You can't imagine it. Your entire existence is crawling and eating leaves. The concept of flying is incomprehensible. But it's your future anyway. We might be the caterpillars, looking at LHS 1140b's empty chrysalis, not understanding that the civilization we're looking for has already transformed into something we can't recognize. Now I need to tell you about what happened when NASA pointed every available instrument at LHS 1140b and started looking not just at the atmosphere, but at the surface. This is where it gets really weird. Webb can't take photographs of exoplanet surfaces. The resolution isn't there. 49 light years is too far for that kind of detail. But what Webb can do is create heat maps. Infrared signatures showing where the planet is warmer or cooler than it should be based on natural solar heating alone. Dr. Duan's team created the most detailed thermal map of an exoplanet ever produced, and they found anomalies. Lots of them. Along the terminator zone, where temperatures should gradually transition from the hot day side to the cold night side, there were discrete hot spots. Concentrated sources of heat that didn't match any natural geological activity. They were evenly spaced, too evenly, like cities. 17 major heat signatures, dozens of smaller ones, all concentrated in the habitable band where liquid water could exist, all producing thermal outputs consistent with industrial activity, power generation, concentrated human activity, except they're not human. They're whatever evolved over there. But here's what made the researchers start checking their instruments for malfunctions. Some of the heat signatures were geometric, not organic shapes like natural cities sprawling across terrain. Geometric circles, hexagons, perfect grids. Dr. Loeb, who's made a career out of suggesting controversial ideas that later turn out to be worth investigating, said what everyone was thinking. Those aren't cities, those are structures. Engineered artifacts on a scale that makes our largest construction projects look like sandcastles. The largest thermal anomaly, located right at the subsolar point, where the star is directly overhead forever, covers an area roughly the size of Texas. It's circular, perfectly circular to within the measurement error of Webb's instruments. And it's hot, much hotter than surrounding terrain. Like it's collecting solar energy and converting it to heat. A solar collector. A power plant the size of a state. Think of it like this. Imagine you're an alien looking at Earth, and you see a massive rectangular heat signature in the Nevada desert that's perfectly aligned to cardinal directions. You'd probably guess it's artificial, right? That's what we're looking at over there, just 1,000 times larger. But there's something else in the data, something nobody expected. On the night side of the planet, where it should be completely dark and frozen, there are light signatures. Faint ones, but detectable. Artificial illumination. They're lighting up the darkness. Dr. Meadows calculated the energy requirements. To illuminate even a fraction of a planetary hemisphere requires power generation on a scale we won't achieve for centuries. We're talking about terawatts of sustained output. They've industrialized their entire world. But industrialization means resource extraction. It means mining, deforestation, oceanic pollution, all the things we're struggling with. Webb should be detecting ecological damage on a massive scale. Deforestation showing up as changed albedo, reduced biomass, altered chemical cycling. Except we don't see that. The biosignatures are strong, healthy, stable. The planet appears to be thriving biologically, while simultaneously supporting a massive industrial civilization. How is that possible? Dr. Frank proposed something that sounds utopian. What if they figured it out? What if they achieved sustainable industrial civilization? What if they're showing us it's possible to have both technological advancement and ecological health? Or, as Dr. Sasolov suggested more darkly, what if they're farming themselves? What if they maintain high biosignatures because they've turned their entire biosphere into a managed agricultural system? What if there's no wilderness left there at all? Earth 3.0 might not be a planet with a civilization on it. It might be a planet that is a civilization. Every ecosystem managed, every organism cataloged, every process optimized. A living machine. And we have to ask ourselves, is that the future we want? Is that the only way technological civilization survives long term? Let's talk about the elephant in the room. If they know we're here, if they've been watching us, why haven't they said hello in a way we can understand? Dr. Shostak spent decades designing protocols for how to communicate with alien intelligence. The assumption was always, mathematics is universal. Prime numbers, pi, the Fibonacci sequence, these are cosmic constants. Any technological civilization will understand them. But there's a problem with that assumption. It presumes they think like us. Dr. Walker studies what she calls assembly theory, the mathematical principles underlying complexity in life. She suggests that intelligence might not be a single thing. Human intelligence is specific to our evolutionary history, our neurological architecture, our sensory apparatus. We think in language because we evolved vocal communication. We think spatially because we're visual creatures with binocular vision. But what if they evolved differently? What if their primary sense isn't vision, but something else? Electrical fields like sharks? Chemical gradients like ants? Something we don't even have a concept for? Think of it like this. Imagine trying to explain music to someone who's deaf, who's never experienced sound in any form. You can describe vibrations, frequencies, mathematical relationships. But the experience of music, the emotion it conveys, the way it makes you feel, that's untranslatable. What if consciousness itself is like that? What if their subjective experience is so fundamentally different from ours that meaningful communication is impossible? But wait, they broadcast our DNA sequence back at us. That's meaningful communication. That's understanding at a deep level. Unless it's not. Unless they're just echoing us without understanding. Like a parrot repeating words without knowing what they mean. Dr. Tarter proposed a test. Send them mathematics. Send them physical constants. Speed of light, Planck's constant, the fine structure constant. See if they respond with acknowledgement or just echo it back. But there's a problem. Any message we send now won't reach them for 49 years. Their response won't reach us for another 49 years. 98 years per exchange. That's not a conversation. That's leaving messages for your great-grandchildren. And here's the really disturbing part. By the time we get their response to any message we send today, both civilizations might be completely different. We might be post-human, uploaded into machines, spread across the solar system. They might be extinct or transcended, or something we can't imagine. We're not just separated by space. We're separated by time, by the speed of light, making simultaneity impossible. Every message is a time capsule sent to an unknown future. Dr. Douglas Vacuc, who designed messaging protocols for SETI, said something that haunts me. We're not talking to them. We're talking to who they were 50 years ago. And they're not talking to us. They're talking to who we were 50 years ago. We're two ghosts reaching across time, trying to touch. But there's another possibility. One that's both hopeful and terrifying. What if they're already here? Not in person. But what if they sent probes? What if, millions of years ago, they scattered self-replicating machines across the galaxy to monitor developing civilizations? What if there's a probe in our solar system right now, watching us, waiting for us to reach a certain level of development before making contact? Dr. Loeb made headlines searching for exactly this. He investigated Oumuamua, the mysterious interstellar object that passed through our solar system in 2017. It was cigar-shaped, tumbling, accelerating in ways that comets don't. He suggested it might be artificial. A probe, an artifact from another civilization. Most scientists dismissed him. But after the LHS 1140b discovery, people started taking a second look at anomalous objects in our solar system. Strange asteroids in weird orbits. Satellites with unexplained acceleration. Small things we'd written off as measurement errors. What if they've been here all along, and we just weren't looking? I need you to consider something that's going to sound crazy, but stay with me. Every satellite we've ever launched, every space probe, every piece of technology we've put into orbit is broadcasting our technological capability to anyone watching. We've been announcing ourselves to the cosmos for decades without even realizing it. And if there's a probe in our solar system, it knows. It's been cataloging our development. It's been sending reports back home. Reports that won't arrive for 49 years. Right now, racing toward LHS 1140b at the speed of light is information about you, about this moment, about what humanity achieved in 2025, information that will arrive in 2074 to beings who might not exist anymore, telling them about a version of us that will be ancient history. We're all time travelers, sending messages to the future, whether we mean to or not. Here's what's keeping astrobiologists up at night. The more we study LHS 1140b, the more it looks like us. Not similar, not analogous. Like us, Dr. Bataya compiled everything we know into a comparison table. Oxygen atmosphere, liquid water, industrial pollutants, roughly Earth-sized, rocky composition, active geology, temperature ranges supporting complex life. Point by point, characteristic by characteristic, it matches. The probability of that happening by chance? Dr. Casting ran the numbers. Less than 1 in 10 million. Random chance doesn't explain this. So what does? The anthropic principle suggests that we find planets like Earth because we're looking from Earth. We're biased toward finding places like home because those are the places we know how to look for, the places we recognize. But that doesn't explain the DNA signal. That doesn't explain the timing coincidences. That doesn't explain why they seem to know about us. Dr. Sasolov proposed something that sounds like science fiction, but might be the only explanation that fits all the data. What if Earth and LHS 1140b were seeded by the same source? What if there's a third party, older and more advanced, that's been spreading life across the galaxy using a template. What if we're both experiments in the same laboratory? Think of it like this. Imagine you're a gardener planting seeds across a huge field. You use the same seed stock, the same planting technique. The plants that grow will all look similar because they came from the same source. Now scale that up to galactic proportions. Ancient civilizations planting life across star systems. It would explain why the biochemistry looks the same, why the evolutionary pathways seem parallel, why we're finding each other now at similar technological levels. But it raises a terrifying question. What happened to the gardeners? Where are the civilizations that seeded us? Are they still out there, watching their experiments grow? Or did something happen to them? The dark forest hypothesis suggests a darker answer. Maybe they're gone because they made themselves visible. Maybe they're gone because something older and more powerful found them. And maybe, by seeding the galaxy with life, they were creating what? A successor species? A backup? A way to survive beyond their own extinction? Dr. Frank asked a question that silenced the room. What if we're the children of a dead civilization? What if everything we are, everything we've built, all of human history, is the seed finally sprouting after billions of years of cosmic winter? What if finding LHS 1140b isn't about discovering aliens? What if it's about finding our siblings, the other seeds that sprouted successfully? And what if the reason we're developing at similar rates, reaching technological civilization at roughly the same time cosmically speaking, is because we were designed to? What if we're meant to find each other right now? But designed for what purpose? There's a concept in evolutionary biology called convergent evolution. Different species, facing similar environmental pressures, evolve similar solutions. Sharks and dolphins look alike because they both swim in oceans, even though one's a fish and one's a mammal. Wings evolved independently in insects, birds, bats, and pterosaurs because flight provides similar advantages. Dr. Simon Conway Morris from Cambridge spent his career studying convergence. He argues that evolution isn't random. Given similar starting conditions and similar environmental pressures, life will find similar solutions over and over again. Eyes evolved independently at least 40 times on Earth. Camera style, eyes with lenses and retinas appeared in organisms as different as octopi and humans, with no common ancestor that had eyes. The solution to sensing light is convergent. Now apply that logic to intelligence, to civilization, to technology. Dr. Conway Morris suggests that technological civilization might be convergent. Any species that evolves high intelligence will eventually develop tools, agriculture, cities, industry, computation. The path might vary in details, but the broad trajectory is inevitable. If he's right, then LHS 1140b developing similarly to Earth isn't surprising. It's predictable. Intelligence leads to questions. Questions lead to science. Science leads to technology. Technology leads to industrialization. Industrialization leads to the exact atmospheric signatures we're detecting. But here's where it gets really interesting. Convergence also suggests that the problems are universal. Energy crisis, resource depletion, climate change, nuclear weapons, artificial intelligence risks. Any technological civilization will face these same challenges. Think of it like this. Every civilization is climbing the same mountain. The terrain is different, the exact route varies, but the altitude checkpoints are the same. Base camp, Camp 1, Camp 2, the death zone. Every climber faces the same challenges at the same altitudes. We're at base camp looking up at someone at Camp 2, trying to figure out how they survived the obstacles between here and there. And they're looking back down at us, maybe trying to warn us, maybe trying to help, maybe just watching to see if we make it. Dr. Meadows analyzed the atmospheric data, looking for clues about which challenges they've solved. The CFC concentrations are declining, slowly but measurably. Like they're phasing them out, just like we did with the Montreal Protocol in 1987. Their carbon dioxide levels are elevated but stable. Not runaway greenhouse effect like Venus. They're managing it somehow. They haven't solved it, but they're not collapsing under it either. There's methane in the atmosphere from biological sources, but also from what looks like industrial capture and utilization. They're using their waste products. They've got circular resource flows. They're surviving. They're managing their planetary crisis. They're showing us it's possible. Unless we're misreading the data. Unless what we interpret as stable management is actually locked in catastrophic equilibrium. Unless they're trapped in a nightmare scenario they can't escape, and we're looking at a planet-wide prison, not a paradise. Dr. Frank studied collapsed civilizations on Earth. Easter Island, the Maya, Rome. Everyone collapsed for different specific reasons, but they all share common patterns. Resource overshoot, environmental degradation, social complexity exceeding sustainable management capacity. He calculated that any civilization faces a critical threshold around type 0.7 to 0.9 on the Kardashev scale. That's when energy consumption approaches planetary limits. That's when you either collapse back down or break through to true planetary management. There's no middle ground. You either fail or transcend. We're at 0.73. They're at 0.9. They made it through. They're on the other side. What did it cost them? How many of them died in the transition? What did they have to sacrifice? What did they have to become? And here's the question that terrifies me. Are we willing to pay that price? Now I need to bring this down to earth. Because all of this, everything we've discussed, it's not just abstract science. It's about you, your life, your future, the world your children will inherit. Let me be direct. The discovery of LHS 1140b changes everything about how we should think about our place in the universe. And it changes what we should be doing right now today in your life. First, the philosophical implications. You are not the center of creation. Humanity is not unique. We are one instance of a pattern that repeats across the cosmos. There are other intelligences, other consciousnesses, other civilizations asking the same questions we ask, looking up at their skies with wonder, trying to figure out if they're alone. You are part of something larger, unimaginably larger. Think of it like this. Before Copernicus, people believed Earth was the center of the universe. Everything revolved around us. We were special, chosen, unique. Then we discovered we're on a planet orbiting a star. Then we discovered our star is one of billions in a galaxy. Then we discovered our galaxy is one of trillions. Each step was a demotion. Each step made us smaller, less central, less special. But also, paradoxically, each step made us more connected. Because if we're not special, then the principles that govern us govern everything. We're part of the universe, not separate from it. We're not observers looking at creation. We're creation looking at itself. And now we know, the pattern that created us created others. We have cosmic siblings. We're not alone. That should change how you see your life. Every petty argument, every status competition, every tribal division, it all shrinks when you zoom out far enough. We're all humans on one planet, looking at another planet with other beings, and realizing the things that unite us are more profound than the things that divide us. Dr. Carl Sagan said it best when describing Earth from Voyager 1, billions of miles away. Everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives on a pale blue dot suspended in a sunbeam. Now there's another dot, another pale blue dot, 49 light years away, where everyone they love, everyone they know, everyone in their entire history lived their lives. Two pale blue dots in an ocean of darkness, finally seeing each other. But here's what this means practically. For your life right now, we know planetary management is possible. LHS 1140b proves it. A technological civilization can survive its industrial adolescence. Climate crisis isn't inevitable. Ecological collapse isn't predetermined. There is a path through. That should give you hope. But it should also light a fire under you, because we don't know how they did it. We can guess from the atmospheric data, but we don't know what social changes they made, what technologies they developed, what sacrifices they accepted. We don't have a roadmap. We just have proof that the destination exists. Dr. Kaltenegger put it bluntly. They made it. That means we can too. But it also means there's no excuse for failure. We can't say it's impossible anymore. They're living proof it's possible. Every choice you make about consumption, about energy use, about political engagement, about what kind of world you're building, matters more now, because we know there's a path through. We just have to find it and have the courage to walk it. And here's something that should fundamentally change your perspective. You are living in the most important century in human history. Right now. This moment. We are the generation that discovered we're not alone. We are the generation that faces the type 0.7 to 0.9 transition. We either make it through, like they apparently did, or we collapse. There is no middle ground. There is no wait and see. The decisions being made right now, in your lifetime, will determine whether humanity has a future or becomes another extinct species in the fossil record. You are not a passive observer. You are a participant in the most critical moment of human civilization's existence. So let's talk about what happens next. Because the discovery of LHS 1140b doesn't just sit in a research paper. It's going to reshape human civilization in ways we're only beginning to understand. Dr. Vakok studies the psychological and sociological impacts of contact with extraterrestrial intelligence. Even though we haven't made direct contact, just knowing they exist changes everything. He identifies several likely scenarios for how this plays out. Scenario 1, the Great Motivation. Humanity unites around a common goal. If they made it through the climate crisis, we can too. Their existence becomes proof of possibility. We stop arguing about whether climate change is real or whether we can solve it and start focusing entirely on how. Political divisions shrink in the face of cosmic perspective. We see ourselves as one species on one planet, and we act like it. In this scenario, the 2030s and 2040s see unprecedented global cooperation. Carbon emissions drop faster than any model predicted. Renewable energy deployment accelerates. We don't just meet climate targets, we exceed them. By 2050, humanity achieves true sustainability, Type I civilization status, and starts looking outward to the solar system with confidence. Scenario 2, the Great Fracturing. Different groups interpret LHS 1140b differently. Some see it as proof we need to change. Others see it as proof that industrial civilization is universal and justified. Religious groups split over theological implications. Do they have souls? Did God create them too? Are they fallen like us or innocent? Political divisions deepen. Some nations prioritize making contact, pouring resources into radio transmission and detection. Others see it as a threat, arguing we should hide, stay quiet, avoid drawing attention. Conspiracy theories explorate. Maybe they're already here. Maybe governments are in contact and hiding it. Maybe they're hostile. In this scenario, the discovery of alien life doesn't unite humanity. It becomes another thing we fight about. And while we're fighting, the climate crisis accelerates. Resources that could go to solving planetary challenges go to military buildups, to competing space programs, to ideological battles. We failed a test that LHS 1140b apparently passed. Scenario 3, the Transcendence Race. We become obsessed with catching up. If they're type 0.9, we need to get there too. If they have planetary engineering, we need it too. If they have technologies we can barely imagine, we need to imagine them and build them. This drives a technological revolution. AI development accelerates far beyond current trajectories. Biotechnology, nanotechnology, quantum computing all explode forward. We make a century's worth of progress in a decade. But there's a dark side. Moving too fast, we make mistakes. We deploy technologies before we understand their consequences. We create AI systems that optimize for the wrong goals. We engineer biology that escapes containment. We build nanotechnology that we can't control. In trying to transcend, we destroy ourselves. Not gradually through climate change, but suddenly through a technological catastrophe. We reach for godhood and fall into oblivion. Scenario 4. The long wait. Nothing dramatic happens. Life continues mostly as before. The discovery becomes a curiosity, a fact people know, but that doesn't change daily life. Like knowing there are galaxies, billions of light years away. Intellectually fascinating, practically irrelevant. We continue on our current trajectory. Slow progress on climate change. Incremental technological advancement. Political dysfunction. Economic inequality. The usual human story. 50 years from now, LHS 1140b is a trivia question. 100 years from now, it's a footnote in history books. We neither unite in inspiration nor fracture in conflict. We just continue, muddling through, maybe making it, maybe not. Dr. Frank calculated the probabilities based on historical precedents of how civilizations respond to paradigm-shifting discoveries. 20% chance scenario 1, 35% scenario 2, 20% scenario 3, 25% scenario 4. Think about that. Only a 1 in 5 chance that this discovery leads to the best outcome. A 1 in 5 chance we rise to the challenge and become the civilization we could be. But here's the thing. Probabilities aren't destiny. They're descriptions of what happens if we don't change course. You can change probabilities. Every person who decides to care, to act, to push for change, shifts those odds slightly. If enough people shift them, scenario 1 becomes more likely, maybe even inevitable. The future isn't written yet. LHS 1140b shows us a path through. Whether we take it is up to us. We're in the final section now, and I need to bring everything together. Because this isn't just about an exoplanet 49 light years away. This is about what it means to be human in a universe that's suddenly much less lonely. Dr. Sarah Seeger, the MIT astrophysicist who's dedicated her life to finding another Earth, said something profound when the LHS 1140b data came in. We've been asking, are we alone for thousands of years? Now we have an answer. And the answer is no. And that means every assumption we've made about our significance, our purpose, our destiny, needs to be reconsidered. Let me tell you what this means at the deepest level. You are a pattern of atoms arranged in a configuration that can think, feel, question, dream. That pattern is temporary. The atoms that make you existed before you and will exist after you. They were forged in stars, scattered across space, gathered by gravity into planets, organized by chemistry into molecules, by biology into cells, by evolution into you. You are the universe become conscious of itself. You are the cosmos looking back at its own origin. And 49 light years away, there's another pattern. Different atoms, probably different biochemistry, definitely different evolutionary history, but the same fundamental thing. Matter organized to consciousness. The universe did it twice. At least twice. Probably trillions of times across cosmic history. You are not a unique accident. You are an instance of a cosmic principle. Matter complexifies, and when it becomes complex enough, it wakes up. Think of it like this. A wave on the ocean isn't separate from the ocean. It's the ocean in a temporary configuration. It rises, it falls, it returns to the water. While it exists, it has a shape, a height, a speed. It's distinct, but it's made of ocean the whole time. You are a wave in the quantum field that makes up reality. You're a temporary configuration of matter and energy that can observe itself, question itself, wonder about itself. And so are they. We're two waves in the same ocean, finally seeing each other across the vast distance, finally realizing we're made of the same thing. Dr. Alan Lightman, physicist and philosopher, writes about what he calls the cosmic connection, the deep, fundamental unity of all things. Not New Age mysticism, but hard physics. Every atom in your body was literally forged in stars. You are made of stardust. That's not metaphor. That's fact. The iron in your blood, the calcium in your bones, the carbon in your DNA, all created in stellar furnaces billions of years ago. And the atoms in whatever beings live on LHS 1140b? Same process. Same origin. Same cosmic story. We are all children of stars. We are all siblings in the deepest sense possible. And that should change how you live. Not in some vague, inspirational poster way. Concretely, practically. If you are a temporary wave in an eternal ocean, then what matters? Status? Wealth? Winning arguments on the internet? Those things are vibrations on the surface of your wave. They don't touch the depth. What matters is the complexity you create, the consciousness you nurture, the beauty you bring into existence, the understanding you develop, the love you share, the wonder you experience. What matters is that you, a configuration of atoms that can think, use that ability to understand the universe that created you, that you look up at the stars and feel kinship with other patterns of atoms doing the same thing 49 light years away. What matters is that you are part of the universe waking up, and you don't waste that. Dr. Sagan, in his final book before his death, wrote, "The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself." LHS 1140b proves he was right. The universe doesn't just know itself through us. It knows itself through them too. Through countless others we haven't found yet. Through patterns of consciousness scattered across 100 billion galaxies. You are not small. You are the size of the universe experiencing itself from one point of view. And that is the most extraordinary thing I can possibly tell you. So, let's bring this home. Let's talk about what you should do with this information. First, change your perspective. Tonight, when you look up at the sky, know that you're looking at a neighborhood, not an empty void. There are others out there. They're dealing with the same challenges we face. They're asking the same questions. They're trying to survive, to thrive, to understand. You are not alone in this universe, and neither is humanity. Second, take responsibility. We know planetary management is possible. LHS 1140b proves it. That means every excuse for inaction is gone. Climate change can be solved. Ecological collapse can be prevented. Sustainable civilization is achievable. They did it. We can too, but only if we choose to. Only if enough people decide that the future matters more than quarterly profits. That long-term survival matters more than short-term convenience. That becoming a Type 1 civilization matters more than maintaining the status quo. You have a choice. Every day, every purchase, every vote, every conversation. You're either building toward the future or clinging to the past. There's no neutral position anymore. Third, expand your circle of concern. The tribalism that defines so much of human culture, the us versus them thinking that drives conflict, it's provincial, it's small. We're all humans on one planet, and we've just discovered we have cosmic neighbors. The differences between nations, religions, ideologies, they're real, but they're small compared to the things that unite us. We're all patterns of consciousness trying to survive in a universe that doesn't care whether we make it or not. We're all in this together. Fourth, cultivate wonder. You live in a universe where matter becomes conscious, where stars forge atoms that become planets, that become life, that becomes intelligence, that looks back at the stars and understands them. You live in a universe where this happened at least twice, probably trillions of times. That is extraordinary. That is miraculous. Not supernatural miracle, but natural miracle. The universe is far stranger and more wonderful than we imagined. Don't lose that sense of wonder. Don't let it become routine. Every time you look up at the night sky, remember, there are others looking up too. Fifth, and this is the most important thing, act like your choices matter. Because they do. You are living in the pivotal moment of human civilization. The next 50 years will determine whether we join the community of spacefaring civilizations or become another extinct species. Whether we make it through the Great Filter or get caught in it. And that outcome isn't predetermined. It's being decided right now by the collective choices of billions of humans, including you. Every time you choose long-term thinking over short-term gratification, you push us slightly toward scenario 1. Every time you choose understanding over tribalism, you push us toward survival. Every time you choose hope over despair, you make the good future slightly more probable. You matter. Your choices matter. Your life matters. Not because you're the center of the universe. You're not. But because you're part of the universe, and the part you play influences the whole. Dr. Bataya, the astronomer who first detected the LHS 1140b technosignatures, was asked what she hoped people would take away from the discovery. She paused for a long time before answering. I hope they realize we're not just observing the universe. We're participating in it. We're part of the story. And the ending isn't written yet. The beings on LHS 1140b, if they still exist, if they're still thriving, they're writing their chapter of the cosmic story. They made it through their industrial adolescence. They achieved planetary management. They became a Type 0.9 civilization. We're writing our chapter right now. Today. This moment. What story you're telling? What future are you building? Because here's the final thing I need you to understand. 49 years from now, when the light currently leaving Earth reaches LHS 1140b, they are going to see us. They're going to analyze our atmospheric composition. They're going to detect our technosignatures. They're going to know we exist. And they're going to ask the same question we're asking. Did they make it? Did they survive? Are they still there? What answer do you want them to find? Do you want them to see a thriving civilization that learned from their example, that solved the climate crisis, that achieved sustainable planetary management, that reached for the stars with hope and wonder? Or do you want them to see chemical ghosts in the atmosphere, the fading signatures of a civilization that almost made it but fell short, the graveyard of another species that couldn't overcome its short-term thinking? That answer is being written right now. By you. By everyone watching this. By the collective choices humanity makes in the next few decades. We have been given an extraordinary gift. We know we're not alone. We know planetary management is possible. We know there's a path through. All we have to do is find the courage to walk it. So here's my challenge to you. Live like you're part of something larger, because you are. Live like your choices matter, because they do. Live like you're helping to write the story of human civilization, because you are. Look up at the stars tonight. Find Cetus. Know that 49 light years away, there's another world, other beings, other conscious patterns in the cosmic ocean. They made it. We can too, but only if we choose to. Only if we act. Only if we become the civilization we were meant to be. The universe is watching, through their eyes, and through our own. Don't waste this moment. Don't waste this gift. Don't waste this life. You are the universe become conscious of itself. Act like it. Before we end, I need you to do something. Leave a comment below answering 3 questions. What country are you from? What time is it where you are? And what's one thing you're going to do differently after watching this? Because I want to see how far this message spreads. I want to see the global community of people who understand what this discovery means. I want to see proof that we can unite around hope instead of dividing around fear. Hit that subscribe button. Share this with someone who needs to hear it. And remember, we are not alone. We never were. The story continues. The future is being written. Make it a good one.